Good morning. This is the first, or the third in our webinar series. We'll get going here. We have Dave Van Laar, who's our engineering manager at IMW Industries. Dave has 10 years with IMW, and he has a mechanical engineering degree from the University of British Columbia. Dave's experience includes 10 years of BC Hydro, as well as several tech manufacturing companies in the Lower Mainland. Dave's been heavily involved in the past in our R&D programs, including increasing the capacity and size of our current compressor system up to the 300 horsepower level, key roles in developing our current pressure reduction system and module technology, which you'll be discussing today. As well as the development on our mobile units. Most applicable to today's discussion, Dave has been integral in the recent development of our full fill technology, allowing us to get a greater fill in transport trailers for CNG, as well as our max offload capacity technology that helps us do industry-leading offload, maximizing the actual capacity of a turnaround on CNG transport. Now, IMW has been manufacturing compressors since 1984 and has been in existence for 100 years, since 1912. We are owned by Clean Energy Fuels of Los Angeles, California, a public company in the NASDAQ, and well known for the development of the natural gas highway across the United States. I'd like to welcome, obviously, all of our professional engineering attendees and make sure that you're aware of our continuing education credit. This session will count for one technical informal hour, and if you want your CPD credit, and I know that many of your human resources departments have gathered you around a boardroom table today, so there could be several of you watching this in one boardroom, please email to webinars@imw.ca the name, job title, company, and email address of each attendee, whether you're individual or by group, and we will make sure that we forward you the required proof for your technical credit. We encourage everyone to join the discussion throughout the session. Simply by using the chat function you'll see to the right of your screen. If you simply enter that, we are monitoring these questions throughout the session, and we'll do the Q&A at the end, and if there's specific pertinent things in the middle, may halt the presentation just to answer those. But please send us your questions and we will respond to them. So again, today our speaker is David Van Laar. He's a professional engineer and manager of our engineering and product solutions group at IMW Industries, and will be speaking on the topic of industrial gas transportation today. And without further ado, here's Dave.
Well, hello everyone. So delivering cost-effective natural gas to your remote facility is the topic today. And so we'll start with a brief overview of natural gas. Some of you are very familiar with this, others not as much. But I thought I'd start with this to at least give some background. So what is compressed natural gas? Basically, compressed natural gas is about 95% methane. We normally store it around 3,600 psi or 250 bar. We use specially designed containers for that. CNG always stays in a gaseous form. It's different than liquefied natural gas or LNG in that sense. Typically, we compress that natural gas from a transmission or distribution pipeline. It's usually distribution grade gas. Natural gas, or CNG, is about 30% lower cost than most of their fuels out there, and has also less greenhouse gas emission. So one of the reasons that CNG is very good as an industrial gas is cost. And as you can see from the graph there, in the past, the cost of oil and the cost of natural gas have been very similar when put on an energy scale. And that's from 2000 to about 2009. Those costs followed each other fairly closely. And once there was some major discoveries of natural gas, the price there was a much larger disparity between the prices. And so today you can see that oil is a lot more money per diesel gallon equivalent than natural gas as a commodity. And when you get into factories and that type of thing using a lot of diesel or bulk oil, moving to natural gas is a much more cost-effective solution. Of course, if natural gas pipelines aren't available, we need to figure out a way to get the natural gas there, and we'll talk about that in a little bit. One of the other benefits of natural gas as an industrial gas is it has a much lower environmental impact. You can see from the graphic there, sulfur dioxides, nitrogen dioxides, carbon monoxides, all those nasty environmental chemicals that we're releasing when burning diesel, they're much less with natural gas, and that allows, when you're getting into issues of burning diesels and having environmental problems, natural gas can often, just by itself, remove a lot of those concerns. The other thing with natural gas is, believe it or not, it is safer. Although it's flammable and it's compressed to high pressures, it's non-toxic, it's lighter than air, and therefore it disperses very quickly if there is a leak. It has a much higher ignition temperature than gasoline or diesel as well. So if there are sparks present or flames present, it takes a lot more to ignite it. It has a very narrow flammability range. It only burns between 5 and 15%. And right now, the CNG industry, as Dave mentioned, we started in this business in about 1984. And so there's been a lot of developments to storage vessels, and the standards there are second to none. And the safety records are also very good. You can see in the graphic, there's more than 20 million vehicles right now in the world running on natural gas. So this is not an emerging fuel. It's been used for a long time and with a good safety record. So where natural gas is mainly focused on in the past is vehicles. And you can see, today, and we're still in that business for sure. We fill vehicles, cars, buses, garbage trucks, and that's been the primary use. And it's been very effective there to, again, reduce costs, lower environmental impact. It's been a good alternative fuel. But the industrial gas concept now takes that compressed natural gas and really moves it to customers that aren't vehicles, that are off of the pipeline, and allows us to provide those customers as well with natural gas to reap some of those benefits. So the high-level view of the high-level concept is basically made up of 5 parts. And we'll go into detail on each part, but I'll give you an overview. So we first start with a gas pipeline. We move then into compression, and typically that's what IMW has been doing for a long time. But instead of filling vehicles, we're actually filling either tube trailers or large industrial gas cylinders with natural gas. So we're transporting them usually by road, but also sometimes by waterways, to a commercial customer. And at that commercial customer site, we introduce decompression and pressure reduction systems to safely remove the gas from the trailer and deliver it to that customer. You'll hear me use the terminology mother station and daughter station. The mother station really is the gas pipeline and the compression, and the daughter station is the decompression and the end customer. So as end users, there's a huge potential for this industrial gas, for natural gas as an industrial gas. And I've attached some pictures there. You can see in the top left, there's a fracking site. A lot of drilling sites are using diesel right now and definitely can use natural gas. There's hospitals who use diesel for heating in a lot of places in even North America. There's power plants that are running off of diesel still today, especially on the Atlantic coast. And there's also, as we continue clockwise around those pictures, there's asphalt plants that are burning a lot of diesel. And then there's also aluminum smelters and other metal manufacturing industries that as well are using natural gas, are using diesel today and could use natural gas. So there's a huge potential for this, and we're seeing as a manufacturer, this demand is picking up very, very quickly, and it's definitely a good business to be in right now, as far as we believe. So let's talk a little bit about the components. Basically, the first component is the pipeline. And so when you're working on an industrial gas project and you want to move gas from one point to another point, you're going to look for a high-pressure pipeline. And the reason is very simple: is if you're compressing gas to about 3,600 psi or 250 bar into a trailer, the higher pressure you start with, the more effective or the less energy you put in when you compress that gas. And they basically have less energy consumption. The location of the mother station, where this pipeline is often flexible. So the customer, the end user, has a factory that's at a fixed location, but the pipeline, they can choose a pipeline often that has a high pressure or is close to the site as possible. You obviously want to reduce the transportation kilometers and also reduce the energy consumption that you're putting in. When going into industrial gas, when you're compressing gas to high pressures and then also expanding it to low pressures later on, you want to make sure that you have low water content in your gas pipeline. What happens is, as you compress gas, it heats up, and when you decompress gas at the other end, it cools down. And we can see, and we'll talk about temperatures a little bit more later on, but you can see very low temperatures that appear from this, and having wet gas causes a lot of issues with ice formations and that type of thing in the decompression equipment. So whenever you're compressing gas from a pipeline, if the water content is not low, we really recommend the use of a gas dryer to bring that water content low. The other thing that you want to keep in mind is using natural gas with at least 90% methane. When you've got a lot of heavy hydrocarbons, when you're getting into a lot of ethane, propane, butane, and such, again, those compounds will easily drop out at the low temperatures. And so when we look at a project, we always ensure that the gas composition of the natural gas is a quality such that we won't have a lot of heavy hydrocarbons dropping out on the decompression end. So we move to the compression, the mother station. Typically, when you're filling tube trailers with gas, you're going to have a lot of horsepower. You're going to have a lot of compression. Depending on the size of the operation, you usually want to fill the trailers fairly quickly. Those trailers, we'll talk about in a little bit, but they're not cheap. You're investing a lot of money in them, and you want to have them on the road as much as possible. So typically, what we've seen is the sites vary between about 500 and 3,000 horsepower, and we often use multiple compressors for that. There's some advantages of using multiple compressors as well, as you get redundancy built in, and you also get lower starting currents on your electrical grid. The other thing that we really focus on with transporting natural gas is our non-loop technology, and it's really important to ensure you're pumping a lot of oil into your gas. And the reason is very simple: is if you have oil getting into your cylinders and injecting into your cylinders, over time it's difficult to continue to remove that oil. And what happens is the oil transfers in the gas and it falls out into the trailers. And you pay a lot of money for a trailer, and suddenly you're filling it up with oil and having to drain it and then dispose of that oil. And with IMW's compressors, of course, we are a non-lube compressor manufacturer. We have less than 5 parts per million of oil even being introduced into the system, and that really helps us not have to worry about having oil collecting into those cylinders. And it gives you the maximum capacity in the cylinder that you can have. One thing to note, too, is that sometimes the best sites are not necessarily near major electric centers or major power lines, and depending on the country that you're in as well, that may not be an option. And so instead of getting a large genset to run electric-driven compressors, we often do engine drive compressors there, where the prime mover is a natural gas powered engine. And there's some advantages to that. And you can see on the graphic there, those particular machines are actually in Indonesia at one of our sites, and they're Caterpillar engine drive units with radiators outside the skid. So at a mother station, we have a few pieces of equipment that are typically there. We have the compressors, which we talked about already. We also have chillers, and we'll talk a bit more about full fill technology. But the chillers are really there to cool the gas. When you take gas and you compress it into a trailer, it heats up. And this is one of the challenges of moving natural gas from one place to the next is the heat generation. So we'll talk a bit about chillers, but basically we send the gas once it's compressed through some high-pressure heat exchangers, and we use basically an industrial-grade chiller to cool that gas before we put it into the trailer. The other thing that we have is fill posts. Basically, these are have flexible hoses attached to them. They're what connect directly to the trailer, and they have different pressures and temperature sensors to ensure that we're filling these trailers to 100% fill, but not obviously over that. There'd be a safety problem, and not under that where we have inefficiencies in transport. So full fill technology, IMW has been working a lot on this. The name of this game in natural gas transportation is to fill your trailers up to 100%. If you're driving back and forth with an 80% full trailer, the economics just don't work as well as if you have 100%. And if you need to buy an extra trailer because you aren't sure you're going to get 100% fill, then that adds a lot of cost as well. So basically, our full fill technology has a few different pieces, but the goal of it is to ensure that every trailer is filled quickly and as completely as possible. And what we're doing there is different ways of cooling. As we talked about with the chillers, we have some other technologies as well that we're working on to make sure that gas is entering as cool as possible. But then also tracking how many pounds or kilograms of gas are actually going into the trailer, and making sure we don't have again too much or too little gas. So it's proprietary technology that we're using, but we are seeing locations all over the world now that are getting these full fills. So the next piece is transportation. The transportation is the most significant cost driver of these projects, and there's a couple different. We'll talk a little bit about the trailers. Obviously, there's different manufacturers out there for the trailers. Some of you may even be on the call. Some of the people we work with. I've picked a few of the popular ones we've worked with, but there's a lot more out there, of course, as well. But essentially, in the industry, there's a few different types of cylinders. There's type 1 through 4, and we'll spend a bit of time going through those. Type 1 is 100% steel cylinder. It's made out of steel. It's fairly heavy. It carries less because of the weight restrictions on transportation, but it's the lowest cost. And so if you've got a site that is, the mother and the daughter stations are quite close, this often works. As well as if you're transporting the gas via a ship or somewhere where the weight is not as much of an issue, these cylinders are good as well. The type 2 is a hoop wrap steel. Basically, it's a steel cylinder, but you take a little bit of weight out of it. Costs a little bit more as well and carries a bit more. Type 3 is a hoop wrapped aluminum cylinder. It's definitely a lot lighter. It has a large payload, but the cost is high compared to steel when you look at trailer per trailer. The last type is a type 4, which is a fully composite trailer. It's very light, has a large payload, but of course the cost is high as well. And our rule of thumb when we recommend trailers is to look at the distance you're traveling. If you're traveling a long distance over a couple hundred or 100 miles or a couple hundred kilometers, you're going to want to go to a type 3 or 4 cylinder because then it pays to spend the money on the cylinders because they're on the road a lot longer. So IMW deals with all these vendors directly. We've also done a lot of work modeling the filling of these trailers. It's not well understood yet in the industry exactly how these trailers are filled and how the temperatures, what temperatures we achieve during filling and during the decanting or emptying of the cylinders. So IMW has actually got some proprietary models we've developed to predict those temperatures and ensure that as part of our full fill technology and also our maximum offload capacity technology that we ensure we fill as much gas as possible and also remove as much gas as possible, again, to help the economics of the projects. So then we get to the daughter station. There's what we call our decompression side. So you've got a full trailer of gas has arrived at your site, and now we need to take that gas and basically pull it down into the end customer's factory or whatever use they've got. Typically, the pressures that the end customer is working with are in the order of a few bar, or 50 to 100 psi. There are some power plants we work with that are much higher. They could be 50 bar. But typically, you're draining the trailers with free flow down to the end use. The first, we'll talk about each of the components in detail, but basically there's three components at these sites. There's a decanting post, which is essentially the opposite of a fill post, to remove that gas from the trailer via hoses. There's a pressure reduction module, which reduces the pressure, as it says, and a heating module, which helps warm the gas up. So the decanting post, typically we're using large 1-inch hoses. We use multiples of them depending on the flow rates of the system. We've got emergency shutoff valves for safety, both manual and automatic. We measure temperature and pressure, again, to ensure that we can remove as much gas as possible from the trailer. And we also have to look at low temperature construction. When we're using a type 3 or 4 cylinder, we will often see temperatures below -40 Celsius or Fahrenheit. And so the materials of construction are very important to look at when we're pulling that gas off. We also provide some overpressure protection just to make sure that the pressures in the trailers haven't gone too high and that the equipment is protected properly. The pressure reducing module, basically it consists of a few different components. The emergency shutoff valve, again for safety. If there's an incident or an ESD, we can isolate the gas and keep it from flowing to the rest of the system. We have heat exchangers. These are high pressure shell and tube heat exchangers that we use, and we first heat the gas. A little bit different than other manufacturers that are out there, but we essentially like to heat the gas first. We believe it's more efficient. And then we regulate the gas down usually in 2 stages with different pressure regulators or control valves. This is really the heart of the technology. The control logic and how exactly this is working is very difficult. Really what you have to do is make sure that you can flow gas at a high pressure and heat it sufficiently, but also flow gas when the trailer is nearing its empty point and not have too much pressure drop. So it has to be designed very carefully, and when you're looking at this type of equipment, you need to make sure you have a supplier that is well versed in this. It looks like it might be easy to do, but it's the control is definitely the difficult part. The other part that's very critical is the overpressure protection. So when you are reducing the pressure, you need to make sure that if a regulator fails or is not operating correctly, you have sufficient overpressure protection to protect the customer's downstream system. When you're dealing with high pressures, 250 bar, 3,600 psi on the inlet, the end customer obviously can't have that going into their system.
Dave, we just got a question here. Julio is asking, do you install a gas meter in the decanting post?
Yeah, that's a good question. Typically, we do not, but we could. Typically, we'll put the meter downstream of the PRS. So on the pressure reduction system outlet is where we'll install that meter. And the reason is pretty simple. Is the cost of the meter tends to be less with a lower pressure rating. So putting a meter on a 250 bar line typically costs more than putting one on a 4-bar line. And so we'll use that meter.
And there was a follow-up question. What fluid is used in the heat exchanger?
Yeah, we'll get to the heat exchanger module in a minute, and I'll maybe answer that there. I just wanted to mention one more thing about the metering as well. When you use a high-pressure meter on the inlet of the PRS or on the decanting post, you have to consider pressure drop, because when the trailer is down at, say, 20 bar or a few hundred psi, the flow rate of the gas has to remain the same. The customer is still using the same amount of gas, but you need to put it through the system. And so the flow meter may be a small flow meter that is good for the high pressure, but when you put the low pressure gas through, your pressure drop is very high. And so getting a meter that's large enough to, handle the low pressure gas and high enough pressure to handle the high pressure gas can be difficult. So yeah, we'll move to the heating control module. We provide heat for the PRM heat exchangers. We typically use a 50% glycol, ethylene glycol water mixture to heat the gas. And the reason is oftentimes the temperatures in the system are quite low, or the ambient's low. In hot climates, we can use a 10% mixture instead of a 50% mixture. But basically, the heating control module consists of a few pieces. It's got an industrial-grade boiler. Basically, it's a gas-powered boiler that heats up, like we said, a glycol mixture. It includes some pumps and water control valves to divert the water flow to the heat exchangers that are on the PRM. And it also houses the PLC and the electrical cabinet. One thing to note with pressure-reducing modules and heating control modules, the pressure-reducing module has a hazardous area around it. We've got natural gas, it's flammable, and so depending on the country that you're in, there's a hazardous area that is generated. And the heating control module typically is non-hazardous. The boilers have open flames. You're not going to put them near a hazardous area where gas could be present. And so these two modules are typically separated either physically just by a certain distance, or by a wall, or by some sort of sealed partition, depending on the design of the unit. And so because it's a non-hazardous area, we also usually include the electrical components there. So the modules we showed you are standalone modules. Some customers prefer to have those. They can mount them outdoors and use them as that. One thing that IMW is working on a lot lately is developing all-in-one pressure-reducing systems. You can see on the right, this is a mobile pressure-reducing system that we're currently developing. We've got 2 prototypes that are in the field, and this is now the second generation that we're working on. Basically, this unit is fully mobile. It can be pulled by a 1-ton pickup truck, so it's fairly lightweight. It can flow about 1,250 SCFM maximum, and basically you can connect your trailers directly to this unit. You reduce pressure via the PRM side, which is on the back, and then it has a sealed wall to the HCM side, which is on the front, which also contains all the controls. The other unit that's shown on the bottom, the CAD model there, is a larger fixed all-in-one pressure-reducing system. Again, higher flows, and often we build redundancy into these systems as well for critical customers. So maximum offload capacity we touched on a little bit already, but basically there's a few different methods that we use to remove as much gas from the trailer as possible. And again, I think the reason is fairly obvious, but I'll explain a little bit that when we drive the trailers away, we don't want to have a lot of gas left in them. If you're driving a trailer away with 25% of the gas in, that means that each trip you're taking, you've delivered less gas than you should be. And so our goal typically is to have between 5 and 10% of the gas left in the trailers, no more than 10% typically. And so there's different ways of doing that. We use 2-line unloading methodologies where possible. Basically, we just have 2 different systems that are pulling the gas off the trailer. One's a high pressure, one's a low pressure. We obviously pay a lot of attention to the site piping sizing and also the PRS sizing to make sure that the pressure drops are very low. The less pressure drop we have, the lower we can empty that trailer to. And we also do scavenging compression sometimes, where we'll actually install a compressor to basically pull the gas out of the trailer and boost it back up to the end user. And so again, depending on your scenario, each of these methodologies can be used, and we've used them successfully. The other thing that we've worked a lot on is scalability. A lot of times customers will start with a smaller rollout, and they'll want to add to it later, or they'll start with a large rollout right away, but want to have some redundancy built in. And so what IMW has done a lot of is developing standard product that we can successfully basically put in parallel with each other. That gives the redundancy right off the bat. It also ensures, because you're ordering a standard product, that you've got a reliable and quality product that's been tested. It's not a custom unit every time. And of course, if your demand increases, you can add more units. And so, as you can see on this photo here, this particular one had 7 2,000 cubic meter PRSs installed in parallel. It's a very efficient system from that point of view.
Dave, just a couple of questions. How far is the longest stretch for transporting gas by virtual pipeline?
Typically, we see about 400 kilometers one way is sort of where it maxes out. But there are a lot of variables that are in play. It depends on your local jurisdictions for how much gas you can transport per trip. But usually, once you're about 400, 500 kilometers, people start looking at LNG, other technologies to do that. We have a lot of projects that are in the sort of 300-kilometer range one way, and they work quite well.
And how much pressure loss occurs when the natural gas is being transported?
The pressure loss, when you fill a trailer, you're filling actual kilograms or pounds of gas. And so when the trailer leaves, typically the gas is warm because of the nature of putting the gas inside the trailer. And so as you drive, a couple hours, the gas will cool down because of the ambient. Although very slowly is what our modeling and actual experience is showing. But the pressure will reduce somewhat because of the temperature decrease. But obviously the kilograms of gas or the pounds of gas remain the same. There's no venting during transport at all. So the gas that you loaded in is the same gas that you're taking back out.
And just one more right now. Where trailers do multiple drops, what metering systems are most commonly used? Turbine or mass flow meters?
Again, it depends on the application, but typically we'll use a turbine meter on the outlet of the PRS systems. Mass flow meters are good as well. Typically we'll use the mass flow meters on the filling side to figure out how much mass we're putting into the trailer, and we'll use a turbine custody grade transfer turbine meter on the outlet. We have also used mass flow meters on the outlet of the PRS as well. So it depends on your application. It depends on the flow rates. Our standard is to use turbine meters on the outlet. Again, as we mentioned earlier, because of cost typically, and the accuracy is very good on them as well. So we'll look at a few case studies. These are projects that IMW successfully rolled out, and it gives you a flavor of some of what's possible for different customers in different places. So the first one I want to talk a little bit about, and this is not actually an industrial gas project, but it's one of the forerunners of this technology, is a city called Urumqi in northwestern China. IMW started filling tube trailers at this site with our equipment about 10 years ago, more than 10 years ago, actually. And this particular company is delivering natural gas tube trailers all over the city from this large mother station that's shown in the picture. What they're actually doing with the gas is they're not fueling a residential or industrial or commercial customer. They're actually fueling vehicles. And so we use essentially a scavenging type, or what we call a daughter compressor, to remove the gas from the trailer and pump it back into vehicle tanks. And since IMW has been involved in this a long time, it taught us a lot about how to fill the trailers effectively and also how to empty the trailers effectively. And so when we got into commercial applications, this was sort of the pilot that we had and the experience that we had gained. Typically, IMW, for the last 10 years in natural gas transport, has been involved in countries overseas. We've done a lot of projects in Indonesia, Thailand, Nigeria, and it's often thought that in North America the pipeline infrastructure is good enough that there's not a lot of opportunities for this. And the first project that really IMW started working on in Canada was East Coast Canada for a company called Cavendish Farms. And this particular project is transporting gas from New Brunswick over a very long bridge, the Confederation Bridge, to Prince Edward Island, and supplying a factory food processing plant with natural gas. It offsets about 22 million liters of heavy fuel annually. This project's been in operation for 3 or 4 years now, very successfully, and it's flowing about 5,600 standard cubic feet per minute. They're using Type 1 trailers. You can see the round trip is about 140 kilometers, so it's a good application for Type 1 trailers. The other project that is a good case study is one that we're running right now in Mexico. It's supplying fuel to a factory, a beer factory, and essentially it's about 160 kilometers actually one way, 320 kilometer round trip. They're using Type 4 trailers. The flow capacity is about 16,000 standard cubic meters an hour, so it's a very large site. You can see on the picture, this is where we're using multiple standard 2,000 cubic meter units in parallel. And this site has been operating for about 6 months now. The other site that we're just shipping our first equipment to right now is a large customer in Australia. This is Northern Australia or Northwestern Australia. And we're providing natural gas into a 100 megawatt power plant. So this power plant currently is running on diesel. The gas pipeline has not arrived yet. It is going to be arriving soon. But in the meantime, it made sense to actually supply gas from a large pipeline to this remote industrial plant. And in this particular case, they're using Type 3 trailers for about a 600-kilometer round trip. So that's the presentation, and I'll hand over to Dave.
Okay, so Dave, we've got a couple of more questions here. How would the system change if used for transporting LNG?
LNG is really a whole different ballgame. LNG is a cryogenic fluid. It needs to be very cool. It also has a much lower pressure, and so the equipment that you're using is entirely different. Our parent company, Clean Energy, and our sister company, Northstar, do a lot of LNG work, and IMW is starting to get into this work as well. But really, you're looking at LNG production, you're looking at cryogenic pumps into trailers, and then you're looking at vaporization at a daughter side from the liquefied natural gas and turning it into compressed natural gas or low pressure natural gas again. So the systems are a lot different. Typically, the costs are a lot higher, and so either you need a very large project to make it work, or you need very long distances to make it work.
Okay. Mr. Chopra asks, does IMW install booster units at the daughter stations?
Yes, and that's what we call them, scavenging compressors, but booster compressors are the same terminology. Again, depending on the customer's outlet pressure, if the outlet pressure is above, say, 10 bar or 150 psi, we want to remove more gas from the trailer. We're not happy just draining the trailer to, say, to 30 bar. We typically want it down to about 20 bar. And so we'll install compression to pull the gas from the trailer and put it into the customer's end use. We also have done some work if the customer needs large amounts of storage as backup. So if the supply of the trailers is not guaranteed, some customers will put in large amounts of storage at their daughter station to ensure that they have a supply of gas. And in that case, we'll also use booster compressors to fill that storage and unload that storage effectively.
And we've got a question, probably the question on most people's minds, on ROI for industrial gas transport. I know there's many variables, but maybe use some of the examples, the case studies you had, just to give a general sense.
Sure. The ROI on some of these projects, quite frankly, is stunning. I can't talk details about customers, obviously, but what we're seeing is that customers can spend several $1 million offsetting a diesel, and they may be offsetting millions of dollars of diesel every year. Typically, the rough cost savings, diesel and natural gas, is you're saving at least 30%. And so depending on how much diesel you're consuming currently or bulk oil you're consuming, a lot of these projects have a payback of 18 months or less, and full payback. It's pretty stunning. And this is, I think, really why this industry is starting to really realize that this is a very, very good opportunity.
One question here that came in that I hear continuously. Why would you choose CNG transportation over LNG transportation?
It's a very good question, and probably not an easy one to answer. It depends who you're talking to. But in the context of this, of what we're talking about today, industrial gas, CNG, rolling out industrial gas in compressed natural gas is a fairly simple undertaking. There's not a lot of, there's capital costs for sure, but it's a lot less than LNG typically. It depends on where your LNG source is. So if you've got an LNG offload facility, say by a port, or you've got an LNG production facility very close, LNG could make sense depending on where your final customer is. But if you've got nothing and you're starting from scratch, producing LNG is an expensive, I shouldn't say expensive, but it costs a lot to get going. The small scale is already very large. And when you've got a lot of the projects that we're looking at, the flow rates and the actual gas that we're transporting is not large enough to justify the capital expense of the LNG production. Yeah.
Okay, so Dale is asking, are you providing gas directly to truck fleets? If so, what is the DGE delivered cost, dollar per DGE?
Yeah, definitely we are doing that. That's has been our main focus, as I mentioned earlier in the presentation, is actually fueling truck fleets or bus fleets or whatever you may have with natural gas. The delivered DGE price, again, it depends on where you are, which area of the world, but also which area of the United States you are. Typically, the cost savings on diesel to natural gas delivered is 30 to 50%. And that's definitely something that IMW can help you with for sure.
Okay, Gary's asking, does IMW conduct functionality tests under severe climatic conditions, in particular for the mother compressor station?
The answer is yes, to a limited sense. It really depends on what the tests need to be. IMW, when we test our compression equipment at our factory here, we put it through different ambient scenarios in terms of the gas supply. So we can heat the incoming gas up to reflect what would be at site. We also do some simulations to ensure that if the ambient's high, we are going to have the desired performance. Oftentimes, when we're testing the compression equipment here, we don't actually run it at, for instance, 50 Celsius if you have a 50 Celsius end-use application. But with modeling and with the studies and the experience we've had, we can correlate that very well. IMW does have a lot of experience with running compression and decompression equipment in very hot climates. And so we believe with the experience and with the testing and the correlations we do, we can successfully test that equipment and ensure it will run properly.
Okay, Berna is asking, if one were loading trucks, would you need a PRS also or just a compressor?
On the loading side, you just need compression. The PRS is to pull the gas from the trailer to an end use. If you are loading trucks at a daughter side, so you've got, you don't have a pipeline, you're going to transport the gas, and then you're going to take the gas from the trailer and fill a fleet of vehicles, which is what we mentioned in northwestern China, what they're doing. Then you would, instead of a PRS, you'd actually put in a booster compressor or a daughter compressor or a scavenger compressor, depending on the terminology, and use that to take the gas from the trailer and compress it into your vehicles.
Okay. Mark is asking, what model booster compressor do you use for a daughter station filling vehicles? Is there a vehicle dispenser involved?
Yeah, we use our IMW50 technology as a booster compressor. We have different ways of configuring it, and so it's our own proprietary compressor frame that we use for the boosters. And yes, basically, from the booster side, the discharge of the booster compressor is going to be the same sort of 36 or 4,500 psi that you would use in a conventional station. And so the dispensing, the priority panel, all the other equipment is very similar to what you'd find at a station that is connected to a pipeline. So same dispensing equipment.
Okay, Ryan is asking, what is the typical investment for a daughter station?
Again, it depends on size. Some of our smaller sites providing fuel to a small size factory, you're looking at probably $300,000 to $500,000 on the daughter station equipment itself. The larger ones can be up to $1 million. It really depends on the site.
This is a question I hear a lot. What's the price range for the tube trailers, cheapest to the most expensive you've seen?
Usually, again, depending on the size, there's different lengths and different classifications, but the tube trailers typically run from about $200,000 a piece to about $400,000 to $500,000 a piece. And again, depending on your distances and your flows, you may need 6 to 10 of these. So the tube trailers typically are the biggest investment, but they're obviously also critical to the application.
This is an interesting one. Do you recommend transportation through tube trailer in case of bad road conditions in the countryside? Is there a safety worry?
Yeah, that's a good question. What we've found is most of the applications we have, the road networks are fairly good. But if you've got hazardous road areas or unpredictable road surfaces, it's definitely something you'll have to put into the equation of your ROI and also into the feasibility studies. It's hard to answer the question, it's a bit generic, but the short answer is when you've got high pressure natural gas and you're transporting it, the containers are very safe, they're very tested, the trucks are the technology is not a problem, but it's going to be more of an ROI and a commercial impact if you've got bad road surfaces.
Okay. I'm not sure that you'll be able to answer this, Dave, but do insurance rates vary for fuel haulers based on using class 1, 2, 3, or 4 tanks?
That's a very good question. I honestly do not know. We definitely can get back to you on that one. We have contacts that would be able to find that out.
Okay. Where in the Americas can one visit an NGV filling station fed by trailers, like, say, Titans? Alice is asking.
In North America, as far as I know, there's no NGV, which is filling vehicles with natural gas at a daughter station. As far as I know, they don't exist. But there are several sites in North America that are using trailers to unload into industrial uses like factories. If you contact our sales group, we definitely can figure out those locations and tour you through if you're interested.
Okay, we've got a ton of questions coming at us here. Can CNG be offloaded directly to underground cylinders and later have vehicles filled from it, just as in the diesel environment?
It's a good question, and the short answer is no. The reason is you need to compress it, and gas, when you have natural gas or any type of gas, it flows via pressure differential. And so your trailer has a high pressure, your storage might have a low pressure, and so for a while they'll drain and they'll eventually equalize. But equalization is not good enough. You want to remove all the gas from your trailer and put it all into your storage, and that requires some form of compression. And that's typically where we would install our booster or scavenging compression to pull the gas from the trailer into the storage.
Okay, we're at 55 minutes. I think we'll cut it here. Thank you very much, Dave. Thank you, everybody, for the significant number of questions. Just so everybody knows, these presentations are edited and posted to our website. As well, the recordings are posted to our YouTube site. You can go to the YouTube site today, and you will see the previous 2 presentations already posted that you can utilize. Feel free to use as training or marketing materials. You will shortly, within a week, also have access via our website to the presentations. Again, we will send out a survey after this that will also point you towards the upcoming 3 new presentations. May the 22nd, LNG fueling station technology by our friends at Northstar. On June the 23rd, Steve Yubora is joining us again for facility modifications. This is an interesting industry generic presentation on what you should consider if you're converting your fleet to CNG in your facilities where you service these vehicles. On July the 24th, potential for biomethane as a fuel for fleet vehicles. Interesting presentation. So I encourage you all, go to our website, click on these, sign up as often as you like. We're thrilled to have you join us each time. Again, for our engineering friends who are joining us, all you professional engineers, please send in your name, email address to our IMW Webinars email address so that we can send you a confirmation for your informal education credits. And I believe that is all we have for today. Thank you for your questions. Oh, one last thing. Additional information. You can go to the website under Contact Us if you'd like additional information. There's 2 ways. There's a generic form you can fill in, send it in if it's just a general question. If you've got a specific fleet requirement, you can go to our RFQ form and it gets real detailed. You can send over the specs you're looking specifically for and we'll get back to you right away. So once again, thank you for joining us. Please join us again next month, and we look forward to continuing the series for you.